Yo, what's up? It's Alan Everson again and welcome to another video. For this video, we are in chapter 5, Ethernet, and we're going to discuss the summary of this chapter. So for this chapter, it have different sub chapters. First comes the introduction, the Ethernet protocol, the address resolution protocol, the LAN switches, and lastly the summary. So Ethernet protocol. So Ethernet operation, LLC and MAC sublayers. So we have the Ethernet, one of the most widely used LAN technologies, and the Ethernet standards define two-layer protocols and layer 1 technologies. So this is the Ethernet. This is the illustration. So LLC and MAC sublayers. LLC handles communication between upper and lower layers. The MAC constitute the lower sublayer of data link layer. So this is the illustration of data MAC sublayer. Data encapsulation, frame assembly before transmission, and frame assembly, disassembly upon reception of data. Provides three primary functions: the frame delimiting, addressing, and error detection. So the MAC is responsible for the placement of frames on the media and the removal of frames from the media. So media access control, carrier sense multiple access or CSMA process. So we have this connection based access. This is illustration. So this is just a continuation of the media access control. So the MAC address or Ethernet identity. So we have here the layer 2 Ethernet MAC address is 48-bit binary value expressed as 12 hexadecimal digits. IEEE requires a vendor to follow these rules. One must use that vendors assign OUI as the first 3 bytes, and all MAC addresses with the same OUI must be assigned a unique value in the last 3 bytes. So this is the frame processing. So this is one of the MAC address assigned to workstation, servers, printers, switches, and routers. And example MAC addresses are 00-09A-3C-78-00. So Ethernet encapsulations. So earlier versions of Ethernet were slow at 10 Mbps. Now operate at 10 GB per second and faster. So Ethernet frame size. Ethernet 2 has IEEE 802.3 standards define the minimum frame size as 64 bytes and the maximum as 1518 bytes. So this is an illustration of the frame size, as well as this one, the IEEE 802.3. So this is the MAC address and hexadecimal. So this is a presentation of MAC address. The unicast MAC address. This is an illustration for broadcast MAC address and for multicast MAC address. Though MAC address is the address, this address does not change, while the IP address similar to the address of a person based on where the host is actually located. End-to-end connectivity, MAC and IP. So IP packet encapsulated in an Ethernet frame. End-to-end connectivity, MAC and IP. So data link layer is an illustration. So 5.2 address resolution protocol. Introduction to ARP. ARP purpose: sending node needs a way to find a MAC address of the destination for a given Ethernet link. So this is the illustration. So ARP table used to find the data link layer address that is mapped to the destination IPv4 address. ARP request layer 2 broadcast to all device on the Ethernet LAN. So ARP process communicating locally. So this illustration, and broadcasting an ARP request. ARP reply with MAC information. Adding MAC IP to map in ARP cache. Forwarding data with MAC address information. So ARP role in remote communication. If the destination IPv4 host is on the local network, the frame will use the MAC address of this device as the destination MAC address. If the destination IPv4 host is not on the local network, the source uses the ARP process to determine a MAC address for the router interface serving as the gateway. In the event that the gateway entry is not in the table, an ARP request is used to retrieve the MAC address associated with the IP address of the router interface. For removing entries from an ARP table, so the ARP cache timer removes ARP entries that have not been used for a specified period of time. ARP tables on the networking device. So this command is show IP ARP. How ARP can create problems. So this is the illustration. ARP uses broadcast overhead on media on security. Mitigating ARP process. This is segmentation. Each computer has its own collision domain. So 5.3 LAN switches. Layer 2 LAN switch connects end devices to a central intermediate device on most Ethernet networks. Performs switching and filtering based only on the MAC address. Builds a MAC address table that uses to make forwarding decisions. Depends on routers to pass data between IP subnetworks. So the switch MAC address table. Duplex setting. So this is a half duplex CSMA or CD, and unidirectional data flow, higher potential for collision, and hub connectivity. So this is the full duplex, point-to-point only, attached to dedicated switch port, requires full duplex port on both ends, and collision-free, collision detect circuit disabled. So auto MDIX. MDIX auto detects the type of connection required and configures the interface accordingly. Frame forwarding methods on Cisco switches. Store forward. Store forward switch receives the entire frame and computes the CRC. So cut through switch. A cut through switch forwards the frame before it's entirely received. Memory buffering on switches. Port-based and shared memory buffering. This port-based memory buffering. Frames are stored in queues that are linked to specific incoming and outgoing ports. Shared memory buffering deposits all frames into a common memory buffer, which all the ports on the switch share. Fixed versus modular configuration. So power over Ethernet. So fixed versus modular continuation is the sum of the illustrations. So module options for Cisco switch slots. So this is the SFP modules, the Cisco Optical Gigabit Ethernet SFP, the Cisco 1000 base T copper SFP, the Cisco 2 channel 1000 base BX optical SFP. Layer 2 versus layer 3 switching. So this is the comparison of layer 2 switching and layer 3 switching. Cisco Express Forwarding. Cisco device which support layer 3 switching utilize Cisco Express Forwarding or CF. So two main components of CF operation are the forwarding information base or FIB and the adjacency tables. types of layer 3 interface. So switch virtual interface or SVI, the routed port, and the layer 3 Ethernet channel. So configuring a routed port on a layer 3 switch. So these are the configuration, is the commands, that the syntax that you have to input when you are configuring a routed port on a layer 3 switch. So that's all for our video. Thank you for watching.